Thank you, man.
Yeah. Okay, let's go ahead and get started. Our next speaker is going to talk to us about pen testing, which is new for this conference. That's kind of one spot. Some of us who traditionally do networks, and web app testing is sort of something that's a little specialized if you don't do it. In my case, I don't have web apps, so I don't have to test them. So we appreciate it. Jeremy, go ahead and introduce yourself. You'll do a better job than I will, I'm sure.
Thanks. All right, Jeremy Druin. I'm web application and database security specialist. Do a lot of application, especially web application pen testing, some database pen testing, and do network pen testing as well. So basically I was going to cover some background information because I'm looking at a real specific niche of web pen testing today, and that's looking at HTML5 pen testing. Mainly this was going to revolve around web storage and different kinds of transmission formats for the Web 2.0. Most of the talk is actually just going to be demonstrations. So web storage is probably going to be the default storage mechanism for Web 2.0 coming up because it's not proprietary and it's easy to use, and support is built directly into the browsers through an API. It acts like a collection of cookies, or a list if you will. Name-value pairs, just like regular cookies, but you can store multiple cookies under these lists. The collections are pretty smart. They can tell you how many name-value pairs are inside. They can let you know if you've already used a key or not. The key is what you store the value under. It's the name, equivalent to the current name of a cookie. And they can also tell you if you've used up all the storage that's allocated. And that's important because one thing we've already noticed is that developers, when they use the web storage, they tend to put a lot of stuff in there. They like to fill it up, basically. But it can hold a lot. A regular cookie holds around 4K maximum. But with the web storage, typically the clients are allowing you to store about 20 megabytes. And the storage is smart enough to where it can actually prompt the user for more storage if you fill it up. And that's 20 megabytes per domain. There's two basic types. Essentially there's two lists. There's local storage and session storage. Session storage is essentially what it sounds like when all the browser windows are closed. It's supposed to go away. The local storage is persisted, so it'll even survive reboots. It's supposed to be stored out to some kind of hard drive, for example. It's interesting to note that the session storage is technically allowed to live past the end of the session by the specifications. So the web storage follows the same origin. As long as the protocol, like HTTP or HTTPS, the domain and the port are the same, then the application is allowed to read the storage or change the storage of the site that wrote it. Now, user agents are supposed to limit the space, and the popular ones do, i.e. Firefox, Opera, etc. And like I said, the session storage is technically allowed to live beyond the end of the session, but none of the major user agents actually support that. They unallocate the session storage when all the browser windows are closed. It has to be all the browser windows, not just the one you're looking at. Bad news is that anything that has worked for a decade to defeat same origin works just fine on defeating same origin for the web storage. There's no difference in the protections that the browser offers. And there's no concept of HTTP only. There really can't be, because the way that you interact with web storage is via JavaScript. If you had an HTTP only flag, you wouldn't be able to interact with it anymore, which would defeat the entire purpose. And there's no concept that I can find of path like you have in cookies. There's definitely no concept of sensitive. There never has been in cookies, and there still isn't. And there's no data typing. Everything's a string. The key that you store the data under is a string, and everything that you put in the value is a string, no matter what it looks like. Even if it looks like a number or whatever, even if it looks like it's binary, it's still a string. And one thing that we've noticed, this is anecdotal, but in a lot of the tests that we've done on sites that are using web storage, we've noticed that the developers pretty well assume that it's actually secure. They're taking data, perhaps from a corporation, they're placing it onto the client's machine on purpose. But they assume it's secure because this is a new concept, a lot of people don't know about it. how could the user possibly ever read this information? You know, it took them a day just to figure out how to use it. So they think that because it's obscure that it's secure. The general abuse cases are basically in two categories. You have the abuse case where you're the user using a site and you want to gain some kind of advantage over that site. So you want to alter your web storage, you want to read it, perhaps try to see if there's any sensitive data, you want to change the values in some way or delete the values. This might be to get horizontal or vertical privilege escalation, you might be just trying to look at the data, could be any number of things. The other general category is that where a malicious agent is trying to read the web storage of an innocent user. So they want to either probably read the information or they want to alter it in order to gain some kind of advantage over either that innocent user or over the site. Now in order for that to occur, you need to inject some kind of a script into the innocent user's browser, and we'll look at that later with the JSON injection. So one of the demonstrations is going to be injecting these scripts into the browser in order to read information out of it. And the way that the demonstration is going to work today is using the JSON, but there's other serialization formats that Web 2.1 uses as well. So serialization just means that when the browser and the server, which don't really have the concept of state, when they pass information back and forth to each other, they agree on some kind of a format ahead of time so that when the information travels back and forth, both the server and the web browser can agree that they can read and write to it based on these protocols. So the SOAP protocol has been used for a long time. It's a particular type of XML. XML itself is still very popular, and JSON is pretty well gaining ground. It may even be dominant by now. It's a lot easier to write and read than the XML because it doesn't take up as much space, so it's a little quicker, and it's a little simpler to format. There are other formats. There's commercial formats. So there's the MS bin one from that Microsoft that's used by Silverlight that you'll see traveling back and forth between Silverlight applications, and then there's the Flash AMF format you'll see between Flash and servers. And those are a little harder to read because they're one of them, the bin is binary, and the AMF is proprietary, so you need a reader like plugins for Burp Suite or something to be able to decode them. And then of course a developer can just make up anything they want. They can agree that their web application is going to read information in a certain way. They might use common delimited list or whatever. So the demonstrations are going to be looking at these two abuse case categories. One is we're going to attempt to manipulate the information in our own browser in order to gain some kind of advantage over the site. And then the other category is going to be trying to inject scripts into other people's browsers in order to read the information out of their web storage or change it in some way. Now any of the serialization formats here will work exactly the same. You would just change what it is that you're transmitting. So instead of transmitting JSON, we'd be transmitting something else if we wanted to do pen tests on these other formats. So the basic architecture of the demonstration is going to be Firefox browser that is talking to a web server running a web application called Matilde. So Matilde is a deliberately vulnerable web application that has all of the OWASP top 10 vulnerabilities in it, plus maybe another half dozen vulnerabilities that aren't necessarily in the OWASP top 10. And it has a page in it that's specifically designed to test HTML5 web storage. We're going to put the Burp Suite application between Firefox and the web server so that we can see all the responses and change them, and we can capture all the requests also and change those. So I'll provide this slide. Any updates on Matilde are at Adrian's site here at irongeek.com. Also, the weaponized Twitter account, they're always tweeted out to that. Plus, there's about 75 or so videos that covers this material plus other material on the weaponized YouTube channel. It's the exact same keyword, and whenever a new video is posted, it's tweeted out to the same Twitter account. So it's pretty much all revolves around that one word there. So we're running Matilda in a virtual machine. It's always kind of a good idea. Gives you a lot more flexibility, and plus you don't really want a vulnerable web server on your host, because every time you plug it in, you got this web server running that's vulnerable, and people could use that against you. So running on a VM. And the HTML5 stuff, if you go under the cross-site scripting category, category 2, and go down against HTML5 storage, it's that page. Okay. So the way this page works is when you browse to it, there's JavaScript running that goes ahead and puts 5 values into your HTML5 web storage. And you can see that 2 of them are actually displayed on the screen here. The reason that the other 3 are missing from the screen is because the developer is hiding those from you. So one of the goals of this page is to read the other 3 values. To do the demos, we're going to use some scripts that are already written, which will save us a lot of time. And we're going to input those into Firebug, which is an add-on for Firefox. It provides a console that we can enter the scripts into and run them. So the goal here again is we're looking at our own web storage that the site has set on our browser. We want to try to read the values, change the values, add values, and delete the values. The basic code we're going to use is just some JavaScript, and all it does is for both types of web storage, the local and the session, it's just going to run these loops, these for loops, and grab all the key value pairs out of the local, then grab all the key value pairs out of the session storage, put them into the variable. Firebug has this keyword console that we can spit the output out to the screen when we get done. So first things first, we're going to give a try at reading our own web storage and see what this site has placed inside. Okay, so we ran our 2 loops, grabbed all the information out of the web storage, and displayed it to the console. So here we can see that we've actually got the 2 values that were displayed on the screen that we knew were in the web storage, plus we've got the other 3 values that were set by the page secretly, and then we have 2 additional values that are set by a totally different page that we visited in the site that happened to put stuff into web storage. So remember, there's no concept of path. So if one page sets some web storage, the other pages are going to be able to read it. And we've been able to read all the web storage out. Doesn't seem like much, but if the developer is putting something inappropriate in there, when you're doing testing for the customer, you want to make sure you make a note of that so we can modify that behavior. I don't know if anybody notices a pattern of 3 of the items. It's how the developer is hiding them from you. Yeah, they start with secure dot, right? So they must have some JavaScript if statement or regular expression that's filtering out anything with secure dot in. Very clever. So that's based on real world experience right there. All right, good stuff. So now that we have that basic script that reads the information out, we're going to go ahead and use that in further demos. So what we're going to do now is we're going to actually set some items in the web storage, and we're going to use the set item method of the storage object to do that. And we're going to set an account number. After we get done setting the account number, and oh yes, and the enterprise self-destruct sequence, we are going to use that exact same reader script to read the changes back out. Okay, so now we can see that we have all of the original, values, plus we have the enterprise self-destruct sequence, and we've got that account number. Actually, the account number turned out to be the very top one there, added in. So it was trivial for us to go ahead and just run a very small script to add values into the local web storage. Now, if the site were to read those values and act on them, we could have some kind of a problem, so we'd want to let our client know if that was possible. In a similar fashion, actually in a very similar fashion, we can edit values. Before I do this, let me use one of the features of Matilda. It allows you, after you've kind of hacked on it a little bit, sort of messed it up, You can reset it back to its original state real easily. You hit Reset DB button here, then wait, and then in this new release, it'll actually send you back to the page that you hit the Reset DB button on. One of the newer features in it. Okay, so everything's been cleared out. Go ahead and copy the script that edits the values. If you look at the script for editing values, you would notice that it's just going to use the set item method again. There is no add item method in the web storage interface. Set item with a key that's already been set just changes the item. Set item with a key that isn't set adds the item. Now one of the things that we're going to do here is we're going to run the reader script, then we're going to edit the values, then we're going to run the reader script again because we want to be able to see the difference. So I'll make this window a little bit bigger. We'll run it. And so the value of message of the day, which is the third value down in each of the before block and the after picture, you can see in the second version it says this was set by Firebug console. So essentially what we've just done here is we've overridden the values in the web storage. If the application uses those values for something important, say for example your authorization level, this could be a problem. And some of the applications that I've tested that are using this new technology, we are seeing things like the user's ID is stored in the web storage, the user's current authorization level is stored in there. So, you know, you're level 1 or 10 or whatever. We've noticed that the person's manager, maybe some of their profile information is in there. And as it turns out, in some of the applications, if you change the authorization level, you do end up becoming administrators. Now, in fairness, we've seen people keep that same stuff in cookies as well, so this problem's been around for a long time. Okay. Now, deleting values is a little more granular. You can delete individual values using the remove item method in JavaScript, and we'll do that now. So let's go ahead and reset. Okay, so we'll use our reader script to read everything out. We'll delete a bunch of items from it, and then we'll read everything back out again to see the changes. Okay, so we can see there was a bunch of values set by the page that we already looked at earlier, and then there's less values that survived after we used the remove item. So you can remove one item individually at a time, but an alternative way to do this is there's a method in the API called clear. So if you call local storage.clear or session storage.clear, it just clears it all out. So using that alternative, there were three values left over after our first round of deletes, and now there's just an empty string, 0 values left after the clear method's called because it just wipes everything out. Now, the reason why someone might want to delete the values, I haven't ran into any real-world tests yet for this use case, but what I was thinking was if there was a token that restricted you from being able to look at stuff, you know, kind of like Apache has, you know, a file that can keep you from seeing things or whatever. Maybe you could delete this out of the web storage and gain some kind of access. Depends on the logic used by the program. Okay. So the perspective there is that we were trying to gain some kind of advantage over the application in our own browser with our own web storage. But what if you wanted to do something to the web storage of someone else? You would actually need to run the JavaScripts in their browser in order to change their web storage. For that, we're going to use a page that is also under the cross-site scripting category. It's in the persistent, and it's the add to your blog page. This is a great page for learning about cross-site scripts of just about any kind. Okay, so for this one, the script we're going to use is it's pretty much an old script. It's been around for a long time. The guts of it is right here. It's the document.location. All that does is it redirects anyone who visits the page to a page under our control. There's a page already built into Matilde for you. It's under Others, Data Capture Pages, And if you just visit the page or get someone to visit the page, such as through the document.location, anyone visiting this page will have the post parameters, the get parameters, and the cookies, and anything you pass to the page logged into a database and also a text file. There's a link that'll take you over to the view capture data page where you can see the information that's logged. So when we visited that page, our PHP session was captured and logged. If you're ever doing kind of like Net Wars, King of the Hill kind of stuff, this is a pretty good page to lay some scripts onto like a blog or something, and then wait for somebody to visit it. Of course, you'll get their session, and then you can log in, authenticate as them. So we're going to delete the captured data. We're going to go back to add to the blog page. Speed things up. I've just bookmarked a lot of these, but they're available in the menu on the left. Okay, and the first one, all we're going to try to do is get anybody that visits this page to give us their information. And what we're going to specifically try to capture is the local storage. So we can put some words in here. I think I heard this last night. All right. So we're going to save the blog entry. The blog is displayed, and we got shuffled over to the data capture page when the document.location script ran. And it grabbed our local storage, which was our target. Now I'm definitely almost certainly going to have to reset the database. We're going to keep it back here on this page over and over again. Oh, wasn't fast enough. Let's see, let's go to bookmarks, home, just to get somewhere else other than that poison page. Let's reset the database to get rid of that script we injected. Okay, now we can go back to the add to your blog page. Okay, so the obvious problem with that demo is the user's going to notice. They went to one page and they ended up on another site. That is obvious. Now, I've given this talk a couple of times, and I've actually had some people say our users wouldn't notice, but they probably would, honestly. So we're going to improve on this a little bit. What we're going to do is, and the main guts of this one is right here, we're going to use a script that has a bunch of stuff in it, but the main point of it is right here. We're going to open up a background request. And when the user visits the page, our JavaScript that we've injected is going to run. It's going to send them to the exact same data capture page, but it's going to do it as a background request. So in the foreground, you're not going to notice anything, or at least you shouldn't if it works right. We should get the exact same information captured, but the screen shouldn't flicker or anything like that. They're certainly not going to be redirected to this other server, hopefully. Okay, so we'll give it a try. Okay, much better. So there wasn't any obvious, redirection or anything like that. Everything looks like it's pretty normal. Just got the text out here at the bottom. No big deal. So we'll go to View Capture Data, see if anything actually happened in the background. Okay, and there it is. So there's the local storage, session storage, and their PHP session ID. It all happened in the background. This is the one I actually use at work because, for obvious reasons. The first one was just more of to build up to it. Okay, so we'll reset the database because that script is still waiting for us to visit that page, and if we visit again, it's going to keep doing it. And that's why the add to your blog page is under the persistent cross-site scripting section, because it's persistent, it's stored in a database, and every time that anyone visits the page, it's the gift that keeps on giving.
So this is great for when you're working with other people.
Right. So if you're, well, the other thing is it's almost a way to spam your script out there too. So if you don't really know who is going to visit the page, and especially if you don't know when they're going to do it, you just kind of throw the script out there, cast your net, and then just wait for a little while. If it's a popular site, it's just going to take a few seconds. You're going to start getting all kinds of hits. Now, of course, your goal may be to log in as an administrator, so you may have to filter through all the just regular users. Of course, you could you can increase your chances a little bit. You could go to the site, like say if it's a blog or something, you could go to the site and purposely click on a particular administrator and try to put like their user ID or leave them some kind of a message or whatever, you know, something to try to hurry things up a little bit. Spirit phishing, I guess. Okay, we can add and edit values and delete values the exact same way we did it in our own browser. The only difference is we just copy and paste the script into this cross-site script and then drop it onto the page and wait for someone to visit, and it'll run in their browser. Whoever it is that the web storage is being targeted, you have to get the script to run in that browser. All right, so this next one just sets a bunch of items and stuff. Okay, and what I've got the script designed to do is it throws out a snapshot of the web storage prior, and then it runs our script, and then it throws out a snapshot of the web storage after. So just by visiting this page, the web storage was a certain way, and then we set a bunch of extra items that we can see on the screen here in the second window. That way we get a good visual. So we've pretty well shown that we can control 100% all of the web storage in our own browser. We can control anyone else's web storage if we can get JavaScript to run in their browser. So the lesson of all this is that you want to instruct your development teams that the web storage is essentially 100% insecure, or it is unsafe to put any kind of information in there that you consider to be classified as internal or classified as secret or whatever your classification system is. Okay, so next I wanted to look at a way that we could inject some of these scripts besides just putting them on this blog page, a way that's a little less obvious. And to do that, we're going to look at a page in Matilde that uses JSON. The way it works is, let's capture the request so that we can see it a little easier. But the way it works is we pick a tool, so Nexpose in this case, and we hit lookup. Okay, so we'll capture the request in Burp Suite so we can see it a little bit better. And we can see that we must have picked tool 7. Okay, so tool ID is 7, and that's getting sent to the web server. And also the button we clicked has a value of lookup tool, and it's getting sent to the web server as well. Of course, the number 7 is more interesting. That's the number of the tool that we picked. So the number 7 goes off to the server. Server reads the database, pulls the information out, formulates a JSON, and sends it back so it can be displayed on the screen. Now, we know that the site is allowing us to input information, whatever number the selection represents. The question is does it include that input that we're sending in the response, first of all? And second, if so, does it properly encode what we sent in so that when it's reflected back to us, it doesn't execute in the browser? So we'll start to check those two questions now. So those are the two basic questions of essentially pen testing a cross-site script is number 1, is there any input that we will be able to see again? And number 2, is it properly encoded when it comes back out? All right, so instead of the number 3 here, why don't we enter in just this marker, canary, and we'll forward it, and this time we're going to capture the response that comes back from the server instead of letting it go back to the browser. We're just going to search for the word canary. And we can see it shows up. So the JSON that comes back, the tool requested ID that was sent in, comes back to us. The other thing is I went ahead and sent in some brackets just to see if the output, when it's coming back to us, was encoded or not. And it turns out it's not encoded. So this page has a chance of being vulnerable to cross-site scripting because they're not properly encoding the output that's in the response. Okay, we'll go ahead and let that go back to the browser. Hit forward, let it go back to Firefox. Doesn't display anything because the data was nonsensical. All right, so the next step is we think they're vulnerable to cross-site scripting. Let's see if we can actually get a script in there. To do that, we need to take note. Let's send this in one more time. It's easier to see. We need to take note of where in the response this lands. We saw that the word canary landed in a certain spot. Okay, we'll send it again. Forward. Search. Okay. So our injection is landing right here. It's important to note that we can't really influence the information that's output by the site up to our injection point, because that's written prior to our injection. We can, however, influence what comes after the word canary, because we could just replace that with something else, some kind of other JavaScript that we want to run. However, note that the site is going to print that pen test tools, brackets, squiggly stuff, no matter what we inject, because it's basically hard coding all the stuff before the word canary and all the stuff after the word canary. If we don't deal with that stuff at the end after the word canary, we're going to get some kind of JavaScript error, because that stuff just by itself, out of context, is just some weird random text, and it's going to break the JSON parser. So that's okay, we can deal with that. All right, let's let this go on back. Okay, we'll choose another tool. So, actually, I'm sorry, I'm going to forward it one more time. I wanted to capture some text. I don't want to have to type that out, so I'm just going to copy it. But the way that we would be able to figure this out manually is just back up off the word canary. So right before the word canary is a double quote, so type a double quote. And before that is an open bracket. There, before the word tool ID requested. So type a closing bracket to match it. There's another open bracket before the word query. Type a closing bracket to match, and then there's an open paren, type a closing paren. So we could close this off manually, but to speed things up, I'm going to copy it from here. All right, so we copy, forward to let that request go back, restart. All right, tool number 10. Paste. So now, after the number 10, the legitimate ending will show up. Then we got to deal with the fact that the site is going to inevitably print that out on its own, and we want to get rid of that stuff. So we'll just use JavaScript comment to comment out anything that will be output by the site. This is the exploit right here. This is what will allow us to get a script in. Then for the payload, we can just put something like an alert 0 as a proof of concept to see if it's actually going to work. Okay, and I copy this for future reference. Forward it back to website, and there it is. So the exploit worked. It broke out of the JSON context, let us insert any script that we wanted. We put the payload of alert 0 in, and it executed. It does help to kind of keep, at least mentally, keep the exploit separate from the payload when you're doing this kind of pen testing. All right, so we're going to ramp this up a little bit. This time, I'd like to have a little bit better of a payload than just popping up an alert box. I've actually seen some pen testers give their customers like alert box pop-up and stuff. It's okay, it's a good visual reference, but it's not likely to actually get the management team to take immediate, drastic action. It'd be better to inject something that shows the connection between the risk associated with the vulnerability and the business that they're in, whatever that may be. All right, so I'm going to borrow that script from earlier, the one that ran in the background, and it sent our information off to that data capture page. I'm just going to reuse that script as the payload here. All right, so we'll shove that in the middle. Okay, now there's going to be a bit of a problem here that we've been ignoring so far. Some of these characters are special characters in HTML or HTTP. So if you send these characters over the wire, the very first thing that gets the request is actually the web server, not the application server. And these special characters or control characters, they could break the parsing and end up throwing an error. What we can do is we can take this entire exploit and payload combination and go over to the decoder tab in Burp Suite and encode it as URL encoding. That's the kind of encoding that web servers understand. And then replace all of this with that magical hex looking stuff and send that over the wire. Okay, now it doesn't appear that anything happened, and it shouldn't because we talked about before that stuff runs in the background. But you can see Burp Suite is blinking like crazy. It's trying to tell us it's captured another request. Well, that request is that background job running over to the data capture page. So we'll go ahead and let that forward. In fact, I'll just turn the intercept off because it's going to go through a request and response cycle. And if we go over to view capture data, oops, get that off for a second. Okay. So, and there's the information that was captured, and it's about our date timestamp 1053. So we can see it worked. We broke out of the JSON. The JSON still parsed fine. No problems, no errors. Then our script ran after that was done. It still wasn't necessarily very good because we had clicked, I'll go ahead and reset the database too while we're at it. We clicked on a certain tool, and as a user, we expect the correct output to come back for that tool. If we clicked on Nexpose or whatever, it should have came back and given us the little informational block about Nexpose that we saw when we started. We can fix that. So we'll just take like Hailstorm or whatever. We turn Burp Suite back on so it'll listen for our request. Okay, so the Hailstorm turns out to be tool number 8. That's fine. We'll forward that onto the server. Let's go look at the response the server gave back, the real response, the legitimate response. Oops, sorry, I went right past it. Okay, so we sent in tool number 8. There's tool requested as number 8. We know everything after that number 8 is what the site should return, naturally, all the way down to the semicolon, which is the end of the JSON. So we're going to copy everything after the number 8. We're going to forward this request on. And this is what it's supposed to look like if nobody's been messing around with the page. Okay, we're going to mess around with the page anyway. So we'll pick like who is, it doesn't matter. It's going to end up showing Hailstorm anyway because that's what we're going to inject. Okay, so number 8, oops, I left the 8 out. All right, so this is what should be returned by the tool. We're going to go in and inject what ought to be returned. We're going to comment out what's really going to be returned with the comment symbols. And then we're going to borrow that script again that's been working so well for us to send people over to the data capture page. And we're going to put that into the payload area, which is right here. Okay, that's got a lot of control characters in it. We're definitely going to need to encode that. Okay, so let Burp Suite decoder also encodes. Do that. We'll paste it in the exploit payload area. I think I got it all. Forward it on. I wasn't fast enough. It actually already started going off to the data capture page. I'm just going to let that go on. I'll turn the intercept off. But more importantly, let's go back to the pentest tool lookup page. So we know that the background job ran and sent us off to the data capture page because I didn't flip over fast enough. But we can also see the page looks perfectly normal. So the page worked exactly as it should have, no problems, no errors, returned all the data it should have returned, but it did send us off to the data capture page. So essentially what we've done is we've built up a more complex JSON injection that will allow us to go ahead and grab the information out of the web storage, or just in this case, just capture the cookies, or whatever the goal is, whatever JavaScript you want to run in that browser. It could be a beef hook, it could be anything, but also have the page work perfectly normally. Arrays. Now you can also do this type of stuff with by modifying the document object model, because what a lot of pages are going to do in Web 2.0 is they're never really going to use the traditional request response model. There's going to be some kind of event, a mouse over, some kind of change in data, a timer or whatever, that's going to cause part of the page to send one of those background requests to go get more information, and it's just going to update just that part of the page. So one way to do some pen testing on that type of stuff, and for this we're going to reset the database and then go look at the HTML5 page again, is you can use DOM injection, document object model injection. HTML5 web storage page. Now this page is vulnerable because it has a security feature in it that actually has a security defect in the security feature. So if we type in the word canary, for example, and then some stuff, you can see it says I can't add key canary because it didn't pass the validation control. Well, the problem is when they tell you what it was that caused the problem, they output it to the screen without output encoding it. So now the security control has a cross-site scripting vulnerability. So what we can do is we can inject our own HTML, okay, that's going to be output into that error, and our HTML is going to execute. Inside of our HTML, we want to execute some local storage .set item, which we said earlier adds items to HTML5 web storage, or we'll change it if the key already exists. Then what we want to do is this table over here, the table that's displaying right here, we want to go ahead and capture that table element into the variable node so we can talk to that table. We're going to, for each item in the node, we're going to delete all those rows out. And then we're going to call the JavaScript that this page uses to draw that table. We can get that just by reading its source code. I have no idea what it does to draw it. I just know you call it and it draws the table. So the reason that we're deleting the table and redrawing it is we want our changes to actually be reflected to the screen so that everything looks normal. So we'll add add new. Now notice that the span tags and all that JavaScript and stuff doesn't display. That's because it's actually been parsed by the web browser. It's not data anymore, now it's something to do. And the only way I could think of to get somebody to guarantee to mouse over this area was to post, whatever you're thinking, please do not mouse over this area. And that's 99% sure they're going to mouse over it. So notice that when we moused over it, it ran our script, which modified the HTML5 web storage. Then it cleared all the nodes out on the screen. Then it went back and redrew the page so that it displays our new information. All right, so that's the end of the demo section. Untitled, this web application, it's free, it runs on Linux and Windows. You're welcome to use it. It's on SourceForge. It's also linked off of irongeek.com. There's documentation for it actually in the project on how to install it on Windows 7. If you want to install it on Linux, probably the easiest way is if you get a copy of Samurai. Samurai already includes it, so that's pretty easy. If you want to put a newer version in, you can go copy the version off of SourceForge and paste it into the /svr/Matilde folder, or back up the old copy if you want first. Now when you do copy things in the Samurai, you have to remember you have to make the code executable. It's going to be read-only when you copy it over. And change the password to the database. The guy that created Samurai, he makes everything, every username, every password for everything Samurai. So the password to MySQL Server in there is Samurai, and you have to go into Matilda and change it from blank, which is the default, to Samurai to get it to work. But that is the easiest way. And the nice thing about Samurai is it already has Firefox loaded up with all these tools. Burp Suite's already installed and ready to go. It's got all these other tools. So, really cool project. And like I said, if you want any updates on this project or the videos, it's this Twitter feed. And then we also have the Matilda channel under the same name, which has, I think it's 75 or so videos. About half of them are on web pen testing. And videos that cover everything that we talked about today are already out there. All right, so open it up for any questions. Yes, sir.
Did, I guess, based on your knowledge, with local storage, you said that it's limited to a certain size per domain. Is there potential for cross-domain reading and things like that?
The same origin policy is supposed to protect against that. So if you want to do cross-domain reading, you need to use the cross-site scripting injection techniques that we looked at. So you would have that background request that we looked at, just change the domain in there to your domain, but it'll be executing in their browser, and their browser will go out to that domain and drop the information off. So now it has to read the information first and save it to like some kind of variable or something, but it's running in the current web browser, so it has access to the web storage, and then it can shoot it across the wire once it gets it written down into some kind of variable. So you can get around same origin. Basically, anything that has always gotten around same origin works perfectly fine with the web storage. So if you're thinking like cross-site request forgery, if you're thinking any kind of HTML injection, anything like that, it all still works. Everything still works just perfectly fine. And for what we're seeing, the cross-site scripting is still a really bad problem in websites. So this testing service is something that I offer to my customers so that they're aware that the developers need to be taught, if it's something important, just don't put it in web storage. So the company should be classifying their data in some way. You know, they might use numbers like 1, 2, 3, 4, or levels like secret, top secret, or whatever. But they should just know that any data that's classified above a certain level cannot be placed onto the client. All right, thanks very much.